Hello and welcome. My name is Aditi. In this lesson, we are going to analyze which of the metrics or factors are important for getting a high-paid job. So let's get started. To do that, we are going to use the correlation heat map. If you do not know what is a correlation heat map, then you can take a pause and go back to the data visualization course, section 3, and come back. We are going to use the heat map function for the Seaborn library. Now, let's take a look at the correlation map. We can see that the problem-solving skill of a candidate has 95% correlation with pay grade, making it the most important factor. Secondly, we can see that financial budget of a company is 90% correlated to pay grade, which is very much obvious. As if a candidate goes to a big company with higher financial budget, then the candidate has higher chances of getting good salary. Other important factors include organization impact, supervision level, contact level, and education level. But experience stays as the weakest factor for pay grade, which means even if a candidate has 10 years of experience, he needs to upskill to get a good salary from an organization. So I hope you understood the importance of these factors to understand the quality of job. Now, let's compare these metrics with each of the jobs and understand the relation between them. To do that, we are going to group the data based on job family description and aggregate it according to the mean function. After that, we are applying a background style and use the red palette to easily identify the difference in values. We can now see that the output tells the average level required for each metric and for each of the jobs, such as we can see that for accounting and finance, the candidates require 4th level of education, 2.25 level of experience, 5 levels of organization impact, 4.45 level of problem solving, etc. And the pay grade level for accounting and finance is really good in comparison to other jobs. You can also visualize these results using line charts also, as you can see. But now it is completely up to you and your audience whether you'd like to display the results using a colored table or a line chart. Now let's also create an interactive data visualization function so that we can visualize all of these columns or metrics one by one separately if required. If you remember, we imported IP widgets for including interactivity into our program. So we will use the magic function, that is @interact, to make a simple function interactive. This option can be really useful if you want to check the relationship between these metrics deeply. Let's explore this interactive function by clicking on this button. Hooray! You can see that we got our output. Now let's change our values for column and column 1 field. We can see that there is no change. If you want to see the changes, we have to again click on the button. Now we can see that the chart is being changed and we can use this interactive function for lots of analysis. In the next lesson, we are going to take a deep dive into the Naukri dataset. Till then, stay tuned and keep learning.
Hello and welcome to this lecture where we will install Python and Jupyter Notebook. And we are going to use this throughout the course. So let us start with any further ado. We will be installing Python 3.6.1. Let us go to google.com and in the search bar type Python 3.6.1 and follow the first link. Scroll down to Windows x86-64 executable installer and click the link. This will download the setup file for Python 3.6.1. As the file is downloaded, install the executable setup file by clicking on it, and now click on Add Python 3.6 to Path. This will automatically add Python to the default environment variable. Click the Install Now and proceed with the installation. Wait for the installation to finish. Then open Command Prompt and type Python to verify if Python has been successfully added to the environment library or not. And that is great. We have successfully installed and added Python to the environment library. Let us check out a very simple code. We see that Python successfully prints the Hello World command. Well, let us now install the Jupyter Notebook. Again, open the command prompt and type pip install Jupyter Lab. This will install Jupyter in our system. You can also use pip install Jupyter Notebook command if the command pip install Jupyter Lab does not work. Brilliant! We have successfully installed Python and Jupyter Notebook in our system. Well, I'm looking forward to meeting you guys in the upcoming lectures. Till then, stay tuned.
Hello and welcome back. In the previous section, we learned about the most interesting topic in Excel, what if analysis. And now in this section, we are going to learn about the linear regression. So let's begin. Regression is a statistical method used to determine the strength and character of the relationship between one dependent variable and one or more independent variables. Regression analysis produces a regression equation where the coefficients represent the relationship between each independent variable and the dependent variable. Our main concern is on linear regression, that refers to the model which is completely made up of linear variables. Let's say we have y as a dependent variable and x as an independent variable. So the linear regression equation is of the form y is equal to a plus bx, where a is the intercept, that is the value of y, when x equals to 0, and b is the slope of the line. If the slope of the line is positive, then there is a positive relationship between two variables. And if the slope of the line is negative, that means there is a negative relationship between the two variables. So this is all about the linear regression. And here comes an end to this lecture, where we learned about the regression, and in the next lecture, we will learn how to perform linear regression in Excel. Till then, stay tuned. Hello and welcome. In this lesson, we are going to find out the top 10 most profitable movies of all times according to the IMDb movie database. Let's first understand how can we calculate the profit of a movie. We all know that every movie has a budget, and after release, they earn some money which is known as gross. Budget is the amount that the producers spend for production, casting, advertising, etc. And gross is the amount of money that they earn by releasing their movies in theatres, selling their movies to TV and OTT platforms, etc. Now, if we have to calculate the profit of a movie, it is very simple. Just deduct the budget from gross and it's done. But before that, we have to convert the gross and budget of the movie from dollars to $1 million. so that it is easily readable to us. After that, we create a new column called profit, where profit is equal to gross minus budget. Hooray! We have created a new feature called profit. Now we have to analyze the top 10 most profitable movies. To do that, we are going to use the sort values function and set ascending is equal to false. Also, as we are only interested in top 10, so we use the head function and specify 10 inside that function so that it will return us the top 10 most profitable movies of all time according to IMDb. But wait, when we look at the output, we can see that there are duplicates in the data set. So, let's remove the duplicates from the data set by using the drop duplicates function and specify keep is equal to first, so that whenever it sees a duplicate value, it keeps the first one and discards the other one. Let's check the top 10 most profitable movies again. Hooray! This time we have no duplicates at all. And we can see that the top profitable movies in the list are Avatar, Titanic, Star Wars, Avengers, etc. One interesting thing is that there are 2 movies from the Star Wars franchise. I hope you're very excited. Let's meet in the next lesson where we will manipulate the duration and language column of the data set. Till then, stay tuned and keep learning.
The Vietnam War ended in 1975. The decades of fighting resulted in more than 58,000 Americans and between 3 to 4 million Vietnamese dead. It was a tragedy that defines an entire generation. In this lecture, we will use various datasets on the Vietnam War to understand this tragedy and also sharpen our visualization skills. There are 3 datasets in CSV files and we will be using all of them. Let's start with the first one. The first one is of the Vietnam War timeline and the fields are year, aggregated number of US troops present in Vietnam, aggregated US fatalities, aggregated ARVN fatalities. ARVN stands for Army of the Republic of Vietnam. ARVN began as a post-colonial army and was closely affiliated with the United States. The next column is of aggregated NVA and VC fatalities. The NVA were North Vietnamese regulars sent from north to south. The VC or Viet Cong were partisans, meaning that they had no official uniform, so they used to fight using civilian clothes. They mostly were South Vietnamese born people fighting against the US backed regime and ARVN. The last 3 columns are for herbicide data from 1961 to 71. The US sprayed over 73 million liters of chemical agents on Vietnam to strip away the vegetation that was providing cover for Viet Cong troops. Agent Orange was one of the most commonly used herbicide mixture. This led to poisoning of the soil, river systems, lakes and rice paddies of Vietnam and enabling toxic chemicals to enter the food chain. This herbicide warfare has exposed millions of Vietnamese people and hundreds of thousands of US war veterans as well. The fields are total gallons of herbicide used, total acres affected, total square miles affected. Let's start with the first task. The first sheet will be called Vietnamization. Vietnamization comprised a phased withdrawal of American ground troops and also providing support to make the ARVN self-sufficient. This will be a multi-series bar chart showing the comparison and change in number of US troops fatalities and AVRN fatalities. For the multi-series bar chart, you will need two measures and one discrete field. Moving on to the second task, Operation Range Hand. During the Vietnam War, the US military engaged in an aggressive program of chemical warfare codenamed Operation Range Hand. From 1962 to 1971, the US military sprayed a range of herbicides across more than 4.5 million acres of Vietnam to destroy the forest cover and food crops used by enemy. Plot a bar chart across the years 1962 to 1971 for herbicide use. Also use orange color gradient for highlighting years of maximum usage. We are using orange color gradient because Agent Orange was the main herbicide used. Third task, deaths in Vietnam. This requires us to switch to the next dataset. Let's quickly analyze next dataset, Vietnam War civilians deaths. The first field is deaths by. It's a dimension and this is a field with mixed info. Some fields are of deaths of civilians and armed forces, while others are death caused by various democides. Democide is a term proposed by R.J. Rummel, who defined it as the intentional killing of an unarmed or disarmed person by government agents. The other columns are self-explanatory, like low estimate, middle estimates, or high estimates of deaths. We can either use a new Tableau workbook for this task, or we can import the dataset in the same workbook. Let me quickly show you how to import multiple datasets in a single workbook. As we can see in the data pane, I already have a dataset imported, Vietnam War Timeline. Now I am going to import the next dataset in the same workbook. For this, we will go to the top menu bar and open Data menu. From here, select New Data Source. The shortcut is also given, either it could be Command D or Control D based on if you are on Mac or PC. From Connect pane, select text file and search for Vietnam War civilian death. Press OK. Now go to a new sheet. In the data pane, just above dimension pane, we can see two datasets. Now in this task, you will have to create a pie chart that gives our reader the breakdown of deaths between two sides. The actual deaths of Vietnamese army and civilians weren't available, so there are only estimates. Create a pie chart showcasing and comparing deaths of all civilians and army from North and South Vietnam. Extra marks for showing percentage breakdown in addition to other important labels. Fourth task, age distribution of US fatalities. This requires us to change the dataset again. We will be using our third and final dataset, Vietnam War US Casualties.csv. Let's quickly analyze this dataset. This dataset is of US Army personnel who died in the Vietnam War. It has multiple columns and most of the columns are self-explanatory. There are two date dimensions, born on and died on. More than 58,000 US Army personnel died. Create a histogram of age distribution for US personnel who died. Fifth task, the Tet Offensive. In late January 1968, North Vietnamese and Viet Cong forces launched a coordinated attack against US forces. The US and South Vietnamese militaries sustained heavy losses. But in the next few months, the South Vietnamese and American forces launched a counterattack and won from a technical standpoint or a military standpoint, as they were able to retook many of the cities very quickly. But the Tet Offensive changed the perception of majority of US population that Vietnam War was winnable.
We must say no!
Hundreds of thousands of Americans seeing footage and thinking, if the VC can mount an offensive of this size and scale, then it means they will never surrender. They will never give up. And at some point, the US will give up. This shocked the American public and eroded support for the war effort. Now, after this history lesson, I would like you to create a line chart showing discrete years and months, highlighting the increase in fatalities of US forces starting that offensive. The main years of the Vietnam War were from 1961 to 1975 with the fall of Saigon. Use filters to remove the externals. Sixth task, branch-wise casualties. Create a visualization reflecting US casualty across various branches. You can use the highlight table for the same. Seventh task, fatality locations in Vietnam. Quang Tri and Quang Nam, two provinces, saw fierce battles in South Vietnam. Create a bar chart for all locations based on fatalities and sort the visualization. Eighth and final task, fatalities distribution based on rank. Create a tree map to showcase the distribution of fatalities based on rank. With this, we finish our section exercise. This exercise ensures you get to practice all the visualizations we have learned in this section. The solution for this exercise, if required, is in the next lecture. Have fun and keep practicing.
Hello everyone, welcome back. I'm Aditi. In the previous section, we learned about the VLOOKUP and HLOOKUP functions. And now in this section, we are going to learn about the index and match. So first, let's see, why do we use index and match? And after that, we would move on to applying index and match in Excel. Index and match is the most popular tool in Excel for performing lookups. This is because the index and match is incredibly flexible. Along with vertical and horizontal lookup, we can do a two-way lookup, left lookup, case-sensitive lookup, and even lookups based on multiple criteria. So basically, the index and match is a combination of two functions in Excel. Index returns the value of a cell in a table based on the column and row number, and match returns the position of a cell in a row or column. We might have observed that while using VLOOKUP function, we searched for lookup value only in the first column of the table array. But now with the index and match function, we can look up value at any column index. The other reason for using index and match is that it does not require more processing power, as it considers only the lookup column and the return column, while in case of VLOOKUP and HLOOKUP, it requires more processing power from Excel due to its need to evaluate the entire table array selected. So the index match has its own advantages and is used most frequently and has almost replaced VLOOKUP and HLOOKUP. Now, as that we know why the index and match are used in Excel. In the next lecture, we are going to apply index and match and will visualize their use in Excel. Till then, stay tuned and keep enjoying.
Human beings simply aren't built to function at the cruising altitude of a 747. Everest is without doubt the most dangerous place on Earth.
Mount Everest is a place at once both awe-inspiring and unforgiving. It is where people go to live out their wildest dreams, but many times proving to be too big for even the biggest dreamers. As a reporter from the BBC once stated, when Mount Everest takes a life, it also keeps it. The number of bodies on Everest continues to grow, with climbers dying on its slope every single year. The world's highest mountain is also the world's highest open grave. In the next few lectures, we are going to analyze the fatalities happened on Everest. So let's jump in. The first step is to import the Everest data. You can download the CSV file and the Tableau workbook from the resources section. From connect to a file, select text file, locate the Everest_fatalities.csv and open it. It's a single sheet and data is already pre-formatted so that we can jump to the next step. From bottom left bar, select sheet 1. As usual, let's start by exploring the current data. Right click on the dataset, Everest_fatalities, and then select View Data. Also discussed in the previous lectures, especially the lecture on aggregation and granularity, the first question to be asked is, what is the granularity of this data? Or in other words, what does one row represents? By examining the rows, we can see the granularity is the climber or Sherpa who has died on the Everest. And everything else is an attribute of the climber, including name, age, nationality, etc. So now we have figured out the grain. What should be our second step? We need to rename the number of records field to represent this grain. Hence, we will right click on the number of records and we will rename this field to climber_count. We will be discussing one of the most basic and important charts, the line chart. Actually, we have already worked with line charts in our lecture working with time series data. In this lecture, we will dig deeper into the line charts. Line charts are the most effective way to see the trend over time. Tableau provides us with the option to create both discrete and continuous line charts. We are going to understand the difference between a discrete and a continuous form of a line chart that Tableau plots. Though line charts can be created for many different types of dimensions, you will be mostly using them against the date dimension. Creation of a discrete or a continuous line chart depends solely upon the type of date dimensions we have. If our dates are discrete, then we will have a discrete line chart. On the other hand, if our date is continuous, we will have a continuous line chart. Enough of theory, let's start building our base. We will drag the date dimension and place it in the column shelf. we will get a blue pill for year. This indicates it's discrete. And we also know that discrete pills create headers. Hence, we have headers in our x-axis. Another interesting thing to note is we have missing values of many years. After 1922, we have 1924 and 1934, and then directly 1952 and so on. We can clearly see many years are missing. Just keep this discovery aside for a moment. We will come back to it very soon, I promise. Now drag climber_count measure and place it on the row shell. We will get a line chart. Line charts are a two-dimensional representation of marks. We also need to do some house cleaning, as we have a long axis which is not looking that good. We need to fix this. From top bar in the drop down, we'll select the option of fit width. Much better, isn't it? This is a nice discrete line chart.
Houston, we have a problem.
So what's the problem? As much as Tableau tries to do the right thing with our data, it's not perfect. Let's examine the axis carefully. For initial years, we have tons of missing years. Then we have continuous sets of years. If you ask my opinion, I think discrete view actually misrepresents the data. Why? Because it doesn't show the days nothing was going on. But of course, it also depends on what we are trying to communicate. If our goal was to see the years with maximum or high numbers of fatalities, then missing years won't matter. And we could have also used bar chart. But here, we are trying to spot the trend over our time. And hence the visualization is giving us the wrong representation. Here's a handy tip. Whenever in doubt, ask yourself, are you trying to show comparison or are you trying to show a trend? If you are showing comparison, a bar chart is the right choice. But if you are interested in conveying a trend, meet your new best friend, the line chart. Let's change the date from discrete to continuous. Right click on blue pill of year date and select continuous. Now we can see the trends more clearly. Fatalities have risen much more sharply in recent years. From this example, we can clearly see that the discrete headers would be missing dates if the data didn't have a value for every year. It's up to us as analysts and visualization creators to do the final check to ensure that the chosen visualization accurately represents the data. I hope you are enjoying this lecture. We'll meet you soon in the upcoming lecture on the area charts.
A very big hello and welcome back. In the previous lesson, we have implemented the decision tree algorithm. And in this lesson, we are going to understand the concept of bagging. But before getting into bagging, let us understand the problem statement first. The decision trees can fit a complex pattern, but they almost always overfit if the data is large. By overfit, we mean a model that has high variance in it. So one way to overcome this problem is model averaging. The key tool to do the model averaging is called bootstrap or sometimes resampling. Let us understand the bootstrap estimation with a simple example. Suppose we have n data points and we want to estimate the mean of these data points. So, we draw a sample with replacement b times from this data set, each of size n. We calculate the mean for every sample and collect it. Finally, the estimated mean would be the average of all the means collected on different samples with replacements. Well, we could apply the same to our data sets too, but here our parameter of interest is accuracy rather than a simple mean. The fascinating thing about combining models is, even though we use the same data set with the same model, we come up with a generalized model that works better than a single model. This process is called bootstrap aggregating, or in short, bagging. Let us understand bagging with a simple example. Suppose we have a large data set of n rows and we want to aggregate b different models. So, we draw a sample with replacement from this data set, each of size s, where s is less than n. We create a new model and fit the data to this model and collect the model. We do it b times. Now, to generate predictions, we predict using each model on the whole prediction data. If we are solving a regression problem, then we take an average of all predicted values. And if we are solving a classification problem, we can do a voting mechanism between the models to choose the predicted class. Well, there is no strict rule that only decision trees should be used for bagging. We can use logistic regression or SVM as well. But the high variance nature of decision trees makes them a preferable choice in the group. And now it's time for a quick recap. In this lesson, we have learned the concept of bootstrap and bagging. In the next lesson, we are going to learn about random forest algorithm. Till then, happy machine learning. Hello and welcome back. In the previous lecture, we learned about comparison, logical, and bitwise operators. And in this lecture, we are going to learn about identity and membership operators. First, we will start with identity operators. Identity operators compare the memory locations of two objects. Whenever an object or a variable is created, Python always assigns reserved memory to it. Let us check the different types of identity operators that we have. Let us start with is operator, which evaluates to true if the variable on either side of the operator point to the same object and false otherwise. For example, x is equal to 10, y is equal to 10. X is y results true. Z is equal to 20. X is z results false. Next we have is not operator, which evaluates to false if variables on either side of the operator point to the same object and true otherwise. Example, x equals 10, y equals 20. X is not y results true. Z is equal to 20. Y is not z results false. Let us move on to the second operator, that is the membership operator. Membership operators are operators used to validate the membership of a value. Let us check the different types of membership operators that we have. Let us start with the in operator. In operator evaluates to true if it finds a variable in the specified sequence and false otherwise. For example, t is equal to 3, 6, 4, 1. 3 in T results true. Next we have is the not in operator, which evaluates to true if it does not find a variable in the specified sequence and false otherwise. For example, T is equal to 6, 3, 9, 0, 5. 5 not in T results false. So in this lecture, we learned about identity and membership operators. Next, I have a short quiz for you to test your learnings about operators. And in the next section, we are going to learn about strings and string methods. Till then, keep enjoying Python.